Today we're taking a look at section 12.2 on measures of central tendency. A measure of center is a value that gives us an idea of where the center of the data set is located. And we have actually four measures of center that we're talking about here. The mean, sometimes called the arithmetic mean, the median, the mode, and the mid-range. So we'll begin with the most common measure of center, which is the mean or the arithmetic mean. What we do is add up the values we have and then divide that sum by the number of values. And I need to add this sample mean is designated by, and I need to get my pen working here, by X bar. So note that you need to put the bar over the X in your notes. So this is a new symbol for you. It's a summation symbol. And it means we simply sum them or add them up. So what it's saying, X are the values that we have in our data list, and N is the number of values. So this is telling us X bar, as it's called, the sample mean, X bar, is found by adding up all the values in our list and dividing by the number of values. The population mean is calculated in the same manner, except we use a different symbol. It's a Greek letter. Mu is the Greek letter that we see here. That's the population mean. And again, we're going to add up all the values in the population and divide by the number of values. Capital N is designating the number in the population. Lowercase n in the previous formula designated the number in the sample. So fairly simple for those two. If we have a frequency table and we want to calculate X bar, what we're going to do is multiply each of our values times its frequency and then add those up, and then in the denominator we divide by the sum of the frequencies. Sum of the frequencies will give us actually N, the number of values in our list. So basically we're doing the same thing, it's just that they've replaced N with the sum of the frequencies. So I'm going to put that over here. Sum of the frequencies is the number of data values. But in a frequency table, what you'll have is a list of values, and then you'll have like 2, 1, 5, 7, and so forth under the frequency column. So it's telling how many times each value is repeated in the list. The weighted mean is called a W. We use a W for that. That is the sum of the values times the frequency, again divided by the sum of the frequencies. Basically what happens is this frequency over the sum of the frequencies gives us a percentage as a decimal. So we're weighting the values, and so we'll take a look at that because that's the way I calculate grades. So next we have the median. What we do for the median is we arrange the data values in order of increasing magnitude. That means from low to high. If the number of values in the list is odd, the median is the middle number. Okay, so let's say this is our list of values. The middle number is the 2, so the median would be 2. And notice I do have them in increasing size, in the order of increasing size. If, on the other hand, we have an even number of values, okay, and here we have 6 values. The median is found by taking the mean of the two middle numbers. So we would take 6 plus 7 and divide it by 2. That means our median would be 6.5. So it's halfway between the two middle values. So that one goes with number 2. In a frequency distribution, the position of the median is at location. You take the number of values plus 1 and divide it by 2. Number of values plus 1 and divide it by 2. So let's see what would happen in this case if we were looking at number of values would be 5 plus 1 would be 6, divided by 2 is 3, so it's the third number. Okay, in this case we had 2, 4, 6 numbers. 6 plus 1 would be 7, divided by 2, it would be located at 3.5, so halfway past the third value. So we can see it actually works for those as well as for the frequency tables. Mode is the value that occurs most frequently. If each value occurs only once, we say there is no mode. Don't put 0 because that could be a possible mode. If two values occur most frequently, there are two modes, and the data is called bimodal. Bi meaning two, bimodal. If three or more values occur most frequency, then one of two things occurs. Either all of them are called modes, and the data is called multimodal. In my stat book and in my stat class, that's actually what we do. But for Math 152, we do the second option because that's the way our textbook handles it. There is said to be no mode. So you can see there is even a difference of opinion among experts in the case of number 3. Okay, now finally the mid-range is our last measure of center. We add the high and the low values and divide by 2. So let's look at this list over here. We would take 2 plus the 9, that's the low plus the high, and divide it by 2. 11 divided by 2 would give us 5.5. And on this one up here, we would take 1 plus 5 divided by 2. We're going to get 6 divided by 2, which would give us a 3 for the mid-range. So high plus low, or low plus high, divided by 2. Round-off rule, you carry one more decimal place than what is present in the data set. So for example, these are whole numbers, so I'd want to round my values off. Same case over here with these. I'd want to round to the nearest tenth. 3 is fine, 6.5, 5.5. All of those will be appropriate answers for this particular case. Now I also want to mention the distribution shapes because these begin to crop up in our exercises. A uniform distribution is where the bars on our histogram are basically at the same height. They may vary slightly, but basically they're at the same height. That's a uniform distribution. If we have a heavier piece to the left and it gets skinnier and skinnier as you move to the right, it's called skewed right. If the heavier part is to the right and the skinnier and skinnier part goes to the left, it's called skewed left. And if it's somewhat symmetric and in a bell shape, we call that bell-shaped, or later on we'll talk about the normal distribution. And if we have two modes with kind of a lower bar in between, that's called bimodal, where we have two higher bars with maybe a shorter bar in between. So I just wanted to mention those. So that takes care of this lecture. The next thing you should do is take a look at the sample problems.